So both Omega and Tudor have METAS certified watches. What does that mean, and is it a big deal? Today we're going to talk about it. Welcome to Wrist Swap. My name is Harrison. Since Omega started doing METAS certification, everyone's been talking about it. It's been a big distinction of what people have said when they look at Rolex versus Omega. They say, well, Omega is METAS certified. Rolex doesn't have that certification. Does that mean anything? What is the big deal? What is the difference? And what tests are even done to meet that requirement? First, we're going to talk through the difference between METAS and COSC. It essentially tests watch movements to decide if they meet these requirements. So chronometer is a word that's used a lot in watchmaking. Basically, it was a word to describe whether or not a watch could go on a boat and hold regular enough time for them to make a safe and correct journey somewhere. That's kind of the history. So originally when you used to navigate in a boat, you'd look at the sky and you'd use stars to navigate, but if it was cloudy, you had no idea, and so you're kind of just using dead nuts navigation. With speed, time, and bearing, you knew where you were. So time was really important to make sure that it was accurate, and so chronometer was a word used to describe those clocks, essentially, at that time. It's moved into watchmaking, and now it still means the same thing, meaning an accurate watch. And so COSC basically looks at the movement, and it does a series of tests to figure out how well its timekeeping is. Now, different watch companies have different things that they've now added as their own requirements, because COSC, in their mind, doesn't go far enough. And some people don't do COSC because it's expensive to send your movements there, but they still regulate them really well, like Zinn. So it kind of depends on if that label is important to you or not. Rolex, for example, has superlative chronometer rating, and that's because they rate their own watches to a higher standard that they've basically created themselves. Patek Philippe has the same thing. I think Grand Seiko has the same thing. And so when Omega came out with METAS, in my eyes, it seemed like the same thing. They came up with their own specifications. So I want to go through those tests and whether or not they mean anything at all. So the first test is a magnetic resistance test. Essentially, they test the watch in two positions, meaning basically this way or this way, so two of the positions. They put the movement in 15,000 Gauss and try to see how well it keeps COSC specified time. And that's kind of the start of the tests. What does 15,000 Gauss mean in layman's terms? Earth itself is a giant magnet, which is why a compass works. So at Earth's surface, there's about half a Gauss of magnetic field at any given time on the surface of the Earth. A typical fridge magnet has 100 Gauss. There's a lot more equations and information that go into that, but it gives you a little bit of a reference. 15,000 Gauss is 150 fridge magnets all pointed at your watch. So it's more than you will ever encounter. The second test is they do the same as the first test, except now the movement is in the watch case. So it's the total watch goes through 15,000 Gauss, and now they look again at the overall capability of that movement to keep good accurate time while it's subjected to essentially 150 fridge magnets at the same time. The third test is the same as the first two, except it has to do with a little bit of time as well. So this one, what they do is they look at the watch 24 hours after it was in the magnetic fields. So basically to see whether or not it now has an effect on its chronometer specified movement accuracy 24 hours after it was subjected to the overall magnetic field. Then they demagnetize the movement because the steel parts would be magnetized, and then they test its COSC-related capability 24 hours after they demagnetize it. And then they basically look at the deviation between those two. You're allowed between 0 and 5 seconds a day deviation between those two numbers. My Omega Speedmaster, for example, was a 0.9 seconds per day deviation. Test number 4, the average daily chronometric precision of the watch. The test carried out over 4 days. During these days, the watch is tested in 6 different positions and 2 alternating temperature zones. The chronometric precision is checked every single day. At the end of 4 days, the results are used to calculate a daily average deviation or variation. You're allowed between 0 and 5 seconds deviation. My watch was 1.8 seconds. Test number 5 is just power reserve. So if the watch is supposed to have 50 hours of power reserve, they test that it has 50 hours of power reserve while it's in the case. That's basically it. Test number 6 is different than test number 4 because this does the same 6 positions, but it's not over 4 days, and it doesn't have to do with differences in temperature zones. Now it's just 6 positions, and then it takes the maximum variation between them. So let's say one position it's +2, the next position it's -4. That variation or that difference is 6 seconds. So that's what it looks like. What's the maximum difference? And it needs to be between 0 to 12 seconds. My watch, for example, is 2.6 seconds, the max difference between the highest number to the lowest number. Test number 7 has to do with how well it keeps chronometer-related time based on power reserve. If you don't already know, as the watch unwinds, it loses power. It's like pushing against something and then slowly pushing less and less and less. And so because it has less power, that balance wheel isn't going to typically swing as much because it doesn't have the same amount of impulse pushed on that balance wheel. Because power reserve has an impact on time variation, they look at that between 100% power reserve to 33% power reserve. What is the deviation between those two? You're allowed between 0 and 8 seconds a day deviation from 100 to 33% power reserve. The last test is just water resistance. So they take the watch and it says it's supposed to be 50 meters water resistance. So they take the watch, cased up and everything, put it in water, they put it into a pressure tank and they put that pressure on it. They put that tank at 50 bar, or in this case 71 PSI for my Speedmaster, and they leave it there for 2 hours. Then they take it out and they put a drop of cold water on the crystal of that glass. And what that will do is essentially bring out the humidity. What you'll have is condensation on the underside of that crystal if water got or humidity got into that case. So that's how they test the water resistance. Then at that point, they'll inspect it, make sure that it looks good, make sure that it's clean, that it's polished, that they didn't scratch it, that sort of thing, and then it's certified. So as a summary, you'll see that essentially you're looking at magnetic resistance, chronometer specifications in different positions, so positional variance, power reserve variance, and power reserve, whether or not it hits that power reserve, and then water resistance. That's basically the litany of tests. So the question is, what about that is different than normal tests? And the main difference in my mind that most companies aren't already doing is the magnetic resistance. And that's what most people talk about. Why is Omega able to do that? And the answer is in the hairspring. So without going through the whole history of hairsprings, they've gone essentially from what used to be steel to Neurovox, which is a different alloy, to now it seems to be common that people use a silicon hairspring. Silicon is an improvement over Neurovox in almost every way. Temperature resistance, pressure resistance, magnetic resistance, and it's almost completely amagnetic. So it isn't affected by magnets. So if the hairspring, which regulates how that watch operates and how well it keeps time, is amagnetic to magnetic resistance, then you would imagine that the watch itself can handle much higher magnetic fields than it ever used to. So if everyone's coming out with silicon hairsprings, which it seems is going that way, I mean, Ulysse Nardin was the first person to do it. Patek Philippe, Rolex, and Swatch met and came up with that they all wanted to do silicon hairsprings and started inventing them together. Rolex has rolled out their own silicon hairspring in ladies' models, other than their Parachrome, which is also very amagnetic. So does that test and certification mean that that watch movement is better than everyone else's? I don't know. Granted, I don't know how many of those tests other companies do. I'm assuming positional variance and water pressure are done by Rolex at least. Probably done by Tudor as well, given that it's in the same category. Tudor has a silicon hairspring as well, which is why I would assume that they could pass METAS certification. But Tudor only has it on one watch at the moment. So is it expensive? Is that why they don't do it? So that's kind of the overview of METAS certification and whether or not it's worth its salt. In my opinion, I think everyone's on relatively level playing ground when it comes to those certifications. What I will say about Omega is their coaxial movement is the improvement. And I can go through exactly what about it makes it better in another video if you want more explanations. But the amagnetic portion that they tend to talk about the most, I don't know if that's actually a differentiator for them if everyone else also has silicon hairsprings. I still love my Omega watch. I still love my Speedmaster. I love the coaxial movement that's in it. I love that it is amagnetic. I love that it has a silicone hairspring. I just like to be honest about what that means. Till next time, take care.